What are solar panels made of and how do they work?
The solar panels are made of silicon cells which are laminated under glass. And the silicon cells are made from the same material that semiconductor chips are made from that power up computers. So they're about 99.79% pure silicon, very pure silicon. We take these cells and we put a phosphorus layer on it, and basically we have two different materials, the silicon underneath and the phosphorus on the top. And there's an extra electron in one layer. The other layer has a shell that's looking for an electron, and when the sun shines on it, there's enough energy in the sun. If you put the properties right, you can promote the electron to jump from one layer to the other, and through a circuit becomes electricity. A silicon solar cell has what we call a band gap of 0.6 of a volt. So what we do is we join a whole lot of them together to make the appropriate voltage, typically around 24 volts. So the solar panels that are used in, say, residential applications and commercial applications give you the appropriate power, typically in the order of something like 175 watts to 200 watts per panel.
What if your roof is facing northwest or northeast? Can you still put them on, or would they be less efficient?
Solar panels work best when they have a normal incidence to the sun, so the sun's shining straight on them. Because the sun tracks over the sky, you have a compromise of putting it on a north-facing roof, because then it kind of, over the day, it absorbs the maximum amount of power if it's fixed. You can, in more sophisticated commercial applications, they'll have what's called a tracker, and it'll actually track the sun. So typically in the southern hemisphere, we have them pointing north. In the northern hemisphere, they have them facing south.
Would a typical large house in Sydney, say in the suburbs, would that have enough space for solar panels to meet all its electricity needs?
Yes, absolutely. What you'd really need to put on a house, depending on how energy efficient the house is somewhere around probably 3 kilowatts to maybe a maximum of about 5 kilowatts to meet all of your needs. And it's very unlikely for most houses, unless they've got a lot of trees around them or they're overshadowed by other buildings, that you couldn't fit that on your roof.
What happens to these panels during rain or thunderstorms?
Nothing really, they get it clean. So one of the things we say about servicing the panels is just to give them a wash. So we actually have them on the tilt of the house, preferably at least about 15% tilt, and that actually promotes the cleaning process. So the raining isn't a problem at all. You lose a little bit of power when you've got rain and cloud and things like that, but it doesn't stop. If you're talking about lightning or things like that, it's no more prone to lightning than the rest of the house.
How long do the panels last?
Most manufacturers give a 25-year warranty on the panels, so a lot of the times they'll be as long as the roof or longer in there. And even at 25 years, they'll continue to produce.
How are these solar systems connected to the electricity grid?
To put a solar system on your roof, you need a couple of things. You need the panels, and you need some cabling, of course, and the mounting system, and you also need an inverter. And the inverter is to turn the DC power, which comes from the panels, into AC power. And the inverter also is very smart. It actually hooks onto the cables that are coming in from the street, and it gets in what's called in sync. So as the AC power is fluctuating at 50 hertz, the power that comes off your roof will also be at 50 hertz, exactly at the right cycle time. So if your house needs the power, it'll come straight in your house. But if there's an excess, then any excess will go back into electricity wires.
Now, can we talk about the feed-in tariff system? How does the meter work?
There are two forms of feed-in tariffs. In New South Wales, we have what's called a gross feed-in tariff, and in ACT the same. In the other states, they have a net feed-in tariff. And the difference is that under a net system, then it's the excess amount of power that goes back to the grid over and above what you use that you get paid for. And in that case, what happens is the meter will actually go backwards if you generate more than you're consuming. In New South Wales, they've changed the rules, so it's a gross feed-in tariff. So it's every bit of electricity you produce, you get paid for, whether or not you send it back to the grid. And in that case, they have to put in new meters. What those meters need to do is they need to know what power you're sucking from the grid, so they know how much to charge you, but they also need to know how much power you've produced so they can pay you the tariff. And they'll pay you 2, 3, even 4 times as much as what it costs you to buy it.
What happens in a power outage in your area?
What happens is that they usually cut off the power from there, because what could happen is that, say there was a problem in your street and the power lines went down, or the cable fell or something like that, then you really wouldn't want the power system on your house generating power and sending power back into the grid. So someone could be working on the lines and they'll get electrocuted. So typically you're isolated. So if there's a power outage, your panels will also stop producing unless you have a more sophisticated inverter and some control systems, a system in that you can actually disconnect from the grid. If a power outage happened and it was caused by the grid, it would disconnect you from the grid and allow you to generate at the house.
Now, can we look at the renewable energy certificates that people get for these? How does that work for a typical house?
It's a kind of a capital rebate program that the federal government has put in. They look at the amount of megawatt hours the system would generate over the life of the system over typically 15 years. And then they calculate the value of those and then they give you a credit for it. So typically a house can actually get paid for how many RECs or megawatt hours that it would generate at about $40 per megawatt hour. If you buy a system, then when they install it, the person who helps you install it, they will actually calculate those, and a lot of companies will offer to buy those RECs from you, or alternatively you can sell them. There's companies that will buy those RECs from you, and therefore you get the credit straight away to offset against the capital cost, because the capital cost of putting it on your house could cost you, $10,000, and if you can get $5,000 back straight away to offset that, then that's a very good thing.
When someone buys the installation, they get RECs based on the kilowatt hours over the life or over 15 years. But those RECs are indistinguishable from any other REC. So a company, say a utility, could buy them for this year's quota. So aren't you sort of moving future energy and calling it renewable this year?
They can be a bit of a mismatch if there's an imbalance in the system. There has been some discussion about whether that's bringing some of it forward. That might be a good thing, I think. Actually, it might help us meet some of our reduction targets a little bit earlier. We'll see what happens, I guess. If there eventually does become some kind of a carbon price, then these will certainly help.
Do domestic installations form a really big part of our energy?
Typically at the moment, residential systems are not making a large contribution, but the take-up has just really started in the last couple of years. But one of the things solar really is good at doing is at meeting the peak demand. Because we have a lot of trouble in major capital cities and the infrastructure in Australia of meeting the power in, let's say, the late afternoon at the moment, when there's not enough capacity on the grid and there's not enough network to support that as well. And solar is perfect. The hotter and the sunnier it is, the more the air conditioning load on people that are putting in, then the solar can lop off that demand. So even though solar is only very small, 1% or maybe a little bit more now of the total energy bill, it can actually make a substantial contribution to that peak demand period in the afternoon. And I think as time goes on, you'll see it making a greater and greater contribution.